Hello everyone, greeting from Docplexis and very warm welcome to all of you present here. I'm Shifa Sheikh from Docplexis. As we all know, Docplexis is India's one of the most trusted and leading digital platform dedicated exclusively for doctors, focused on enabling medical education and professional networking. So, dear users, we are very excited to inform you that we have launched our new and updated version of DocPlexis application. You can now easily download the application from Google Play Store and App Store and stay updated with latest notifications, important CME sessions, and learning opportunity at all your fingertips. So, I am requesting you to download the application today for a smoother and enhanced learning experience. Today, I am delighted to welcome you all for another very interesting session in ophthalmology, that is heads up vitreous surgery, recent update, or 3D surgery. As we might be aware, advances in vitreoretinal surgery have significantly enhanced surgical precision, visualization, and patient outcome. Among these innovations, 3D heads-up surgeries has emerged as a transformative technology, allowing surgeons to operate with high-definition stereoscopic visualization while maintaining improved ergonomics and surgical comfort. This technology not only enhances depth perception and magnification, but also facilitate better teaching and collaborative learning in operation room. In this session, we will explore the recent updates in vitreous surgery with a special focus on evolving role of 3D heads-up surgical system and their impact on modern vitreoretinal practice. So for this very interesting session, once again, it's my absolute pleasure to introduce our esteemed speaker for today's session, Dr. S. Natarajan. Dr. S. Natarajan is renowned ophthalmologist and Padma Shri awardee, recognized for his lifelong dedication to restoring vision, advancing eye care. With over 36 years of experience, he has performed more than 65,000 exclusive vitreoretinal surgeries, and he has also trained over 68 vitreoretinal surgeons globally, contributing significantly to the field. Dr. Natarajan is especially noticed for his humanitarian work, including performing over 200 complex surgeries for palate injuries patients in Jammu and Kashmir, where he has completed remarkable 47 surgeries continuously within 2.5 days. In recognition of his meritorious public service, the government of Jammu and Kashmir honored him with a state award. His dedication to treating ocular trauma victims has been widely acknowledged in international publication, including the New York Times. Alongside his clinical excellence, he has maintained strong commitments to academic and continues to recognize globally for his contribution to ophthalmology. So we are truly privileged to have with him today to share his valuable insights. So without further delays, I would like to hand over the sessions to Dr. Natarajan. Over to you, sir.
Thank you very much. Thanks, Doc Plexus. So I'm sharing my screen. So the topic for today is the heads-up surgery, which is the latest one with the recent updates. It's a 3D surgery for vitreoretinal diseases. So why heads-up surgery is so important? 3D visualization system allows retinal surgeons to operate looking at a high-definition 3D screen instead of bending their necks into the look into the eyepiece of a microscope. And it's like watching a 3D movie with the 3D glass on the big screen. Same thing as a surgeon, I wear the 3D screen and watch the screen and operate. So the idea is it can see the difference between the two layers. It can be in microns, but in the screen it can be seen as such a thick layer. And traditional vitrectomy surgery range from 30 minutes to over 3 hours in length to complete, depending on the complexity of the case. And the microscope-free design is engineered to improve surgeon's posture and may reduce fatigue. The first concern for a veterinary surgeon is to maintain a comfortable and stable ergonomic position that allows to carry out the surgical procedures safely. And this is my operation theater where all of us are wearing 3D glass and watching the screen and operating. And this has been published in Eye in London in 2018 by Maria Romano and team. So the Indian company also started making it, but this is the first one introduced in 3D in the world was Ingenuity, a 3D visualization system by Alcon. It's a clinical science compendium. This is where they call it a Ingenuity 3D visualization system, where they incorporated a true scope into the system. You can see the beautiful visualization on the monitor. And Ingenuity is a 3D visualization system was developed in collaboration with the True Vision, a 3D surgical, a California-based leader in digital 3D visualization and guidance for microsurgery. It consists of a 3D stereoscopic, high-definition digital video camera and a workstation to provide magnified stereoscopic images of objects during microsurgery. It acts as an adjunct to the surgical microscope during surgery, displaying real-time images or images from recording. And they, as you said, the notable high dynamic range camera, which has increased magnification while maintaining a wide field of view, highlighting ocular structures and tissue layers, which is imperative to visualize the back of the eye. And a high quality precision from start to finish. The high level of precision with the Ingenuity removes the need to refocus without losing any detail. Up to 5x extended depth of focus, up to 48% increased magnification, and up to 42% increased depth resolution and customized digital image. And this is a Indian company, Apasami Associate, who are, I don't have any financial interest. They have made a True Glow video microscope, true colors with full HD and 4K resolution, extended depth of focus. And a True Glow microscope is a stable red reflex, high depth of field, complete 3D setup, toric max overlay guided alignment for toric IOL positioning, 3D squint max overlay marking scale for squint surgeries, patient database software built in, and then a special software for recorded surgery playback visualization in 3D. They also have a high grade passive 3D goggles, spectacle clip on the 3D goggles, full HD, one CMOS, and a 4K camera with an excellent ultra high resolution, full HD resolution of a 4K medical grade monitor, foot switch for recording, start, stop, and image capture, ergonomically designed motorized tiltable stand for 3D monitor, all time hybrid setup, binocular 3D viewing simultaneously enabled. So they also have a separate for a anterior segment and then one for posterior segment. And they also have optional accessories like 4K with a 3D 55-inch medical monitor and a surgeon's chair. And this is a new company which is still not available called the Ocutrex or BOT 4900D, where they are creating a surgical visualization theater. And the this is a ORBOT 4900D. It's a 3D visualization theater setup where you can see the fine high resolution images. And they have a model called Camtrex digital microscope, captures live surgery feed, which is displayed to the three visualization sources depending on surgeon's preference. They also have OR lens, 5K AR XR headset, and two stereo lens 8K 3D glasses free monitor. So the Camtex digital microscope captures digital surgery feed and displays the video image to the display option. You can see the optical zoom is 20x in Octrex, Alcon is 16 to 20, Leica is 16, and Zeiss is 16 to 20. And digital zoom, Octrex has 360 degree times, 360 times, and others they don't have this digital zoom. And the micron resolution result is about 3.5 in Octrex, and 3D is possible in Octron, Octrex, Alcon, and Zeiss. And color spectrum is 69B, and the Alcon, Leica, and Zeiss is 1B. Resolution is MP is 50, 4.2, 2.1, and 8.4 in the Alcon, Leica, and Zeiss respectively. So the OR lens or AR XR headset, the OR VOT displays surgery video feed from Camtrex microscope to OR lens AR XR headset. Here again you see the differences in the OR lens, HoloLens, Bionics, and augment ICS. So here, how it's a 5G enabled, and resolution is about 2,300 into 1,440, which is the best among all available. And a stereo lens 8K 3D glasses free monitor. The OR bot display surgery video feed from Camtrax microscope to stereo lens monitor enable user to see in 3D without head needing to wear 3D glasses. That means you can directly see the screen without any glass interface and do the surgery. And here you have the Camtrax magnification. The first one is just magnified the flower and the seed, a 20x optical magnification, and there's 120 digital magnification and 250 digital magnification. And the C-Luma, the new dimension, fully digital visualization, which is made by Bosch and Lomb. So this is now commercially available. Overtrex is still not available. And here you can see they made a C loop. That means you can see the screen directly in front. Yeah. So here you have the binoculars also. And if you don't want, you can put it up and see through the gap. It's directly into the screen, but you need a 3D glass. So here you see the surgeon is wearing a 3D glass and having the screen in front of the eye. And see, this is how the surgeon can see. And you have the vitrectomy machine and the cutter, the microscope on either side. And this is the C-Luma setup. And you can see all the surgeon and the surgeon's the assistant can see, and you can have an overlay to see where to mark and then also record. And this is in the wet lab. Alberta for making the bionic eye, and I'm going to use the C-Luma, the Bosch and Lomb microscope for that. And it's a 3D, and there's a beautiful view. So I'm making the procar.
But
Quanto tempo tu gli oldo?
You have the 3D glass directly on the screen. You can see multiple monitors. You can use the oil lights where we held at the school and to tell us to training school. So if you want to use the binocular, you can use it, but we are using the glass and seeing the screen around. Okay. These are advantage of good training school where you can teach them and students can learn more things. In your teaching. Thank you.
Thank you.
Wonderful. Thank you.
You're welcome.
And the other one, which I saw there in the Thessaloniki Vitreous School, is by a vision engineering company called the DRV Z1, the future of optical inspection. They used it for optical inspection, but now we can use it in the vitreous lab, but not in the operation theater as of today. So the future of optical inspection is here. This the incredible DRV 71. That's called the DRV stands for Deep Reality Viewer is the world's first and only digital stereo inspection system which creates full 3D HD images that appears to float in front of your eyes. You don't need any special glasses or goggles, and there are no unpleasant side effects. You just sit back and view high definition 3D images with outstanding depth perception as easily as the real life. It is a remarkable invention which is already revolutionizing the way organizations view, capture, and share 3D images of the samples they are studying. They started with a watch, I think, and then fine precision instruments, and now come for ophthalmology. So they have a glasses-free 3D experience, which is an outstanding ease of use, and there's a supreme comfort. The ergonomic design improves comfort, efficiency, and productivity by enabling good posture, reduce fatigue, an exceptional ease of use where minimal setup and is remarkably easy to use with familiar control design specifically for efficiency and convenience. A long working distance and a wide zoom range suit a broad range of industrial and life sciences application which require precise hand-eye coordination, including those typified by aerospace, automotive electronics, material analysis, medical, precision engineering, prototyping, and more. And why travel when you can see the same thing in full 3D HD in real time from the comfort of your own workplace? It saves you time, it saves you money, and it's better for the planet. And DRZ1 short base configuration with illumination from above is suitable for positioning over working area. And the long base with the substage light, so you can have a background light. And this is a powerful combination, ideal for inspection and manufacturing application and real-time collaboration on a global scale. 3D images can be shared across networks to other DRV systems in real time. So this is the glimpses of the where I'm using the DRV system. So where I actually uh, i- so here you see there's no glasses required. You directly see inside, and the other side is the 2D viewing. And you can see Dr. Yannick Lemaire from France, the past president of Gonin Club, and Dr. De Cruz from Moorfields Hospital, London, who are all faculty who are teaching at the Vitreous School in Thessaloniki, Greece. And here you can see. So here you can see how I'm using the DNA. You can take the screen. Can you have the lights off?
I don't know how this works.
One of the you can take the screen. Can you have the lights off? So you can put the I'm putting the indoor illuminator, and you can see on the other screen. But here 3D, I am seeing directly without the glasses. So we are now using a mobile phone to record this, and that's why whatever I'm enjoying, you're not able to demonstrate. But this is a 2D monitor system. And so benefits with the digital 3D vitreous surgery is using the microscope and without the, and then here using the 3D screen. So in this study, comparing 3D and conventional microscope visualization system for macular hole surgery, we found that 3D technology reduces the surgeon's cognitive workload significantly. Additionally, our study demonstrates that type of viewing system has no bearing on the overall surgical time, ILM peel time, surgical complication, visual acuity results, or macular hole closure result. So thank you very much for patient listening.
Yes, sir. Thank you so much, sir, for your wonderful and deep presentation on such an important topic. So, sir, I just wanted to ask, you already covered everything. As an audience perspective, I just wanted to add 2 to 3 questions. Can I go ahead and can I?
Yes, please go ahead. Yes.
In your clinical experience, is there any learning curve associated with transitioning from conventional microscopy to 3D surgery?
Yes, there is a learning curve. That's why veterinary lab is very important, where you can use the goat's eye or you can use the Boynico eye, which is a plastic eye specifically made for trial, so that you can get oriented to the 3D and then how you can have your eye-hand coordination, and then you don't use a binocular. So it's a totally new experience. But once you learn to master the visualization, I think then I don't use anything else now. One that after you cross that initial visual the learning curve, you cross it, and then I think no looking back, because you can teach well, you can see well, and you can operate well.
That's great, sir. And so the next question I would like to ask, how important is image enhancement technology in improving intraoperative decision making, sir?
Yeah, because I think the fine, like 30, 40 micron sensitive, we need image enhancement. And this has filters also where you can alter the size and check for a internal limiting membrane, the other parts of the retina. So I think image acquisition using a digital method is very important. And then magnifying digitally, which doesn't have none of the microscope, but the Ocultrex, which is coming, will have one day.
Thank you, sir. And the last question I would like to ask, sir, as per your clinical experience, how do you see artificial intelligence integrating with digital vitreoretinal surgeries platform in future as well?
I know they already people are thinking about it and they are trying to apply, and particularly in surgery. So since it's a digital microscope and using the AI will definitely we have to learn to assist us rather than AI dictating terms with us.
Okay. That's great, sir. Thank you so much for answering all the questions in detail. So let's
Thank you.
conclude the sessions on behalf of entire Docplexis team and on behalf of entire our audience. We really thanks Dr. Natarajan for sharing the valuable insights and deep practical experience on such an important topic that is the heads up in vitreous surgery, recent updates or 3D surgery. So your session has truly helped bridge the gap between technology and everyday clinical practice. And we also thanks to all our participants for joining us today for active engagement throughout the session. And we hope you found this discussion very informative and clinically relevant. So on behalf of Docplexis, we look forward to welcoming you all our for educational upcoming educational programs. Till then, have a great day ahead to all of you. Thank you so much, sir.
Yeah, thanks all of you.